Assalamualaikum dan selamat sejahtera. Nama saya Muhammad Akmal Hafizi bin Samsuri dan nombor matrik saya adalah CE230027 dan saya akan membentangkan soalan 1A dan 1B. Untuk 1A saya sudah masukkan dekat dalam lab. Okay, so ini adalah coding yang saya buat untuk mendapatkan jawapan 1A. So mula-mula sekali kita kena mencari dia punya PX dan QX, and then kita kena mencari integration factor dia. Lepas tu kita kena pakai formula YI equal to QXI, and then kita apply initial condition. Lepas tu kita dah dapat result untuk soalan 1A. So yang ni jadinya jawapannya adalah X kuasa 4 plus 8Y X kuasa 3 bersamaan dengan 1. Alright, untuk soalan kedua, iaitu homogeneous equation, saya sudah masukkan dekat dalam lab. So ini coding dia. So kita dapat jawapan negatif X kuasa 4 tolak 1 over 8X kuasa 3. Itu saja daripada saya. Dan terima kasih.
Hello, Assalamualaikum. My name is Muhammad Hafiz bin Abdullah. ID number CE 230080 from Faculty Electric and Electronics. Today, I will present question 2. Have 3 questions. Given a second order ODE. The first question is A. Identify the complementary function YC for the corresponding homogeneous equation. The answer for the question 1 is YC A power of X plus B exponent power negative X. The answer is same the coding answer is M negative 1 and M1. For the second question is solve the given second order ODE by using the determine coefficient method. First, we need to assume YP based on Fx. So, the Fx is Hc exponent power of X. And the Yp is Cx power of 2 plus Dx and exponent power of X. Second, check if Yp has the same pattern of YC? If yes, multiply YP with X. If the same pattern, multiply again and again with X until the pattern is not the same. Hence, this is the final YP. So, the result of the YP is this X power of 2 plus dx and exponent power of x. Next, we need to find y prime and y double prime. So, answer for y prime is cx power of 2 plus c plus 2cx plus dx plus d and exponent power of x. For the yp double prime, the answer is exponent power of x and cx power of 2 plus 4cx plus 2c plus dx plus 2d. Next, we need to substitute yp, yp prime and yp double prime into y prime minus y and the result is a exponent power of x plus b exponent power of negative x plus 1 over 4 x power of 2 minus 1 over 4 x and exponent power of x. And the last question is then show that the result will be the same as in question 2b by using the variation of parameter method. First, for the first step, we need to identify a and fx. For the a, we get 1 and the fx is x exponent power of x. Step 2, we need to find yc and let yc y1 plus y2. For the y1, we get exponent power of x and y2, I get exponent power negative x. Next step is step 3, find w. Answer of w is negative 2. Step 4, we need to find u and v. Answer for u is x power of 2 over 4 plus a. And answer for v is negative 1 over 8, 2x exponent power of 2x minus exponent power of 2x plus b. For the step 5, obtain general solution by y sandwich u y1 plus v y2 and the answer is A exponent power of x plus B exponent power of negative x plus 1 over 4 x power of 2 minus 1 over 4 x plus 1 over 8 and e power of x. The answer same with the coding I get in MATLAB. That's all from me, from Hafiz bin Abdullah. Thank you for pay attention what I explain for listen to. Thank you.
Selamat datang and good evening, Doctor. My name is Muhammad Afiq bin Safawi and my maths number is CE230060. So I will continue about the simulation question 3A. So first time we should define the symbolic variable. Next, we should define the equation y prime, which is ay plus g. Before that, we should define the value of matrix a, y, and g in the equation form of matrix. So a here, then g, y, then we define this this equation, which is a multiplied by y plus by g. Next, we display. Then step 2, we find engine values and corresponding engine vector of A to compute the engine value. So engine values is equal to HOA, rename it. So then we extract the engine values, which is lambda 1 equal to engine value 1, lambda 2 equal to engine value 2. Then we should display the value of engine value. We should display this value, lambda 1, lambda 2. So now for lambda 1, the value of lambda 1, which is a minus equal to a minus, so the value of a minus by lambda 1, then multiplied by I as a. This one for lambda 2. So we should display the matrix A minus by lambda multiplied by I. Next, we define the simulate variable, which is x and y, the value of x and y. So next, we should define the vector x and y. Next, compute the matrix vector product. So result 1 equal to a minus lambda 1 multiplied by vector. This one. For result 2, a minus by lambda 2 multiplied by vector. Then we display the equation lambda 1 and the equation lambda 2. So now we should find the corresponding eigenvectors and define the simulate variable, which is s, x, and y. So we define the vector xy as a vec. Then we should assume x. First, we assume x equal to s. So assume x and real. So equal to assume also x equal to s. So for next, we should solve for y. So this is the equation for solving the y equation. So for y1, we is a lambda 1 in the matrix form to 1 multiplied by x plus a lambda 2 matrix to 2 multiplied by y. So equal to 0. Same goes to the y2. So next, we should substitute the solution for y in terms of x equal to s. So when we assume x is s, so we should find the y. So this one's for solve for x. Next is result corresponding eigenvectors. So we display the solution. So display the result corresponding eigenvectors. So for v1, then display y and x. Then for display for v2, the value of y and x. Then we should find the eigenvectors and display y and x without s. So y1 equal to y1 divided by s, y2 equal to y2 divided by s, and x1 equal to x1 divided by s, and x2 equal to x2 divided by s. Next is eigenvectors. So display the solution. So display the solution, display the result eigenvectors for v1, y sama dengan x equal to v1. So next for v2, also again same goes for the v2. So next we define the matrix v1. So the value of this and this is the matrix in v1. So next we display the matrix v1. Okay, then when the value we got, so we should display this is the for display. Next for same goes to the matrix v2. So last is general equation. So as well as x, a and b, so to declare the assembly variable, so the last equation is y equal to a multiplied by asp exponent lambda 1 in the matrix for lambda 1 and x multiplied by v1 plus b multiplied by exponent in the matrix form is lambda 2 multiplied by x, and lastly multiplied by v2. So we should display this one. So then we run. So we get, lastly we get a. So this is the output. So this one, the result is same goes to the calculation. So for v1 we get y negative 1 over 5, x we got 1, for v2 we got y equal to negative 1, x to 1. So last are the y-x equation. So a multiplied by exponent 2 power of x multiplied by x plus b multiplied by exponent multiplied by negative 2 power of x. This is the power of exponent. So minus by a multiplied by exponent power of 2x and divide by 5, and minus b multiplied by exponent the power of negative 2 multiplied by x. So that's all for me. Thank you.
My name is Muhammad Azamuddin Muhammad Afandi. Okay, today I will deliver about my part. Is about question 3b. Question is a system of first order differential equation is given as y prime 1 equal to 5y1 plus 4y2 minus 5x squared plus 6x plus 35, and y prime 2 equal to y1 plus 2y2 minus x squared plus 2x plus 4. The eigenvalue for the system are lambda 1 equal to 1 and lambda 2 equal to 6, and the corresponding eigenvector are v vector 1 equal to 1, negative 1, and v2 equal to 1 and 1 over 4. The eigenvector are linear independent. So we look at the question 1. Write the general solution YC for the homogeneous system. So for manual calculation, is what I get is YC equal to A 1 over 1 negative 1 exponent x plus B 1 over 4 exponent 64. In my MATLAB. This is the result that I get from the MATLAB. Which is we should define x first and then put the values of v1, which is v1. This v1 and this is v2. Lambda 1 equal to 1 and lambda 2 equal to 6. And then we should define the function of YC. And the result is like this. And then we move to the second question, which is determine the particular integral YP for the non-homogeneous system using the undetermined coefficient method. This question is like this. Determine the particular integral. We get the YP equal to CD x squared plus EF x plus GH equal to YP is non-equivalent to YC. You can see here, value CD from S equation find C. First, we need to put A equal to 5112 this, and then put the coding solution equal to linear of A and B. This is the GHA C and D plus C solution for C and D. And then we move to the next part. We need to find the EF value from S equation to find the F and E. Solve the bilinear, explain the solution, and then we get the answer here. Then we move to we need to find the value of GH from 0. Equation to find GH, 54, 12, negative 25, and 5. Solve the linear. We get the answer is like that. Here. For a manual calculation, this is what I got. C equal to 1, D equal to 0, E equal to 0, F equal to negative. Same goes here, G equal to negative 5, H equal to 0. Then we move to the B3, obtain the general solution for the non-homogeneous system. This is what the manual calculation I got. Obtain the general solution. Y equal to YC plus YP, Y equal to A1 negative 1 exponent S plus B1 1 over 4 exponent 6x plus 1 0 x squared plus 0 negative 1 s plus negative 5 0. This is the square from MATLAB what I get. Okay. Question 3b. First we need to put the YC equal to exponent Z as the same as the around the answer. Then we need also put the YP here, and then Y equal to YC plus YP like this. Yeah, like this. We need to we need to determine the x, then we get answer like this. For the question, compute the particular solution y1 and y2 given the initial condition are y1 0, y2 0. We do this. MATLAB. A equal to 1 and B equal to 4. Okay, this is my manual calculation, and I got same as the MATLAB answer. Okay, firstly we need to put the value of S and Y, and then put the solution linear solve S and Y. Display the answer. The last part is we need to put the value from this one, A and B, and then put the value of V1 and V2 equation Y Py, which is this, and then we get the final. Okay, I think that's all from me. Thank you.